Hi guys. So this question is a volume of revolution question. It's one of the trickiest question um, for students to attempt. It's a good question. They've given you a vase, and then the vase is now rotated against the x-axis, and they want you to find the volume. And before the volume, they're asking you a couple of things. They've given you two models. One model is model A, which is a trigonometric function, and another model which is given as an algebraic model. Because it's an AS question, do not think that you need to know or you should be aware of any integration or differentiation of trigonometric functions. We're going to do this without the knowledge of all of that. State the value of A that should be used when setting up the model. So because you know the diameter is 8, so if you think about this shape here, it's looking like that. And if it's like that, that means I know this entire thing has to be 8 diameter. And which means the radius have to be 4. So it's 4 up, which is going to be your A. And that's along that axis is going to be A. So which means A equals 4. That's for part A. Question number, the letter A is going to be 4. Part B. Two possible equations are given. They are asking the distance from the base. Base is here. From the distance from here, how much should I be moving? Where the widest part of the vase occurs. So the widest part is this. That's the widest part. Where is that occurring? And to do that, they want you to do for each model, by the way. So I'm going to do it model by model. Model A. Model A, they want you to find what is the widest part, the distance from the base, how much is the widest part occurred, and then the diameter as well. And I know it's a trigonometric model, and this is the widest. Widest means it's the maximum minimum. So the widest is the maximum point. And then the narrower part is here, that's the minimum. So I know y equals a minus 2 sine 45 over 2x. And in relevance, this, I'm going to find out the maximum point or minimum point. So let's say the maximum for sine would have happened when sine 45 over 2x equals minus 1. That's when the maximum value of y would have occurred. So let's say if your a is 4, y equals 4 minus 2 times minus 1. So let's see, that's 6. The minimum would have occurred for y when sine 45 over 2x equals 1. Because it's going to be 4 minus 2 times 1, which is 2. But the question wasn't the y first part, the I part. They're asking you about the distance, x-axis. But I know the maximum happened when it's minus 1. So I'm going to apply. For this, I'm going to apply and then find out the value of x. So sine 45 over 2x equals minus 1. So 45 over 2x equals sine inverse minus 1. Sine inverse minus 1 is minus 90 degrees. Or you can do 270 degrees. 45 over 2x. I'm going to use the 270 degrees. And 270 degrees means it's going to be 270 times 2. And then divided by 45. So x is going to be 270 times 2 divided by 45 is going to give me 12. I didn't use the minus 90. I've used the 270 because it's on the positive. Even if I use minus 90, I would have had 90 times 2, which is 180, and then minus 180, and then minus 45, which, divided by 45, so minus 180 divided by 45 would have given you 4. So you can either keep 90 or 270 as well. So minus 90 times 2 divided by 45 would have given you minus 4. It's up to you to which one to keep. If it's 12, I've been asked how far, find the distance from, how much should it be moving from the base to get to this point. And I know it has to move 4 across. And how do I know 4 across? So they said it's 12. The x is 12. If it's 12, if x is 12, to figure out the amount that it moved, 12 is what I calculated here, by the way. To calculate the movement from minus 8, because that's minus 8, if it moves 12, it's going to be 4. Or in other words, we can also say that's minus 4. So this should have been minus 4. So then we could have understood that it's going to move 4 to the right-hand side from the base to get to minus 4. So 4. 4 is the movement. So how much distance does it need to move? So distance to move is 4. And what's the diameter of the widest part happening? Diameter. The diameter, we've already calculated it's 6. So it's going to be 12 because it needs to be, 6 is the radius. So that's 6. That gap is 6 here. And then it needs to be times by 2 to find the diameter. For model B. Model B is a simple model. It's an algebraic model. So to find the maximum minimum, I can either complete the square if it's a quadratic. If it's not a quadratic, you have to differentiate. So y equals 4 plus x times x minus 8, x plus 8 over 100. So that's going to be 4 plus x times x squared minus 64 over 100. So before doing the differentiation, I'm going to open the brackets. Plus 1 over 100 x cubed minus 64x over 100. So let's differentiate. That's 0. That's going to be 3 over 100 x squared minus 64 over 100. So 64 over 100. We need to make it equal to 0, by the way, to find the maximum minimum. So that's 3 over 100 x squared minus 64 over 100. If I bring it to the other side, 64 over 100 equals 3 over 100 x squared. X squared is 64 over 3. X is plus or minus 64 over 3. And therefore, x is going to be plus or minus 8 over root 3. So that's the differentiation. They're asking how much is the distance that it needs to move. The distance it needs to move is going to be, that's the x-coordinate. How much does it need to move from minus 8 to get to minus 8 root 3? Because that coordinate should have been in model B. That point should have been minus 8 over root 3. So from 8, how much should it be moving? Is the gap between the 8 root 3, which should be around 3.8 something. The gap from here to get to minus 8.